Hey, today we are going to talk more about some probability and some probability rules. So just a start to chapter 14. So the addition rule is something we've talked about already, but we talked about the addition rule when two things were mutually exclusive or disjoint. So they couldn't happen at the same time. But we have a general addition rule that covers those types of events and also events that aren't mutually exclusive, meaning they could happen at the same time. And so the addition rule was for or probabilities, so we want to know the probability of A or B happening. And so when these two events are mutually exclusive, when they can't happen at the same time, we could just add the two probabilities together. The problem is if they're not mutually exclusive, we end up counting some of the probability twice. And so what we need to do is we need to subtract away the probability of A and B happening, so the probability that they happen at the same time. And so that gets rid of something that's an overlap. I could draw a quick Venn diagram here. And when two events are mutually exclusive, they don't touch. So if this circle represents event A and this circle represents event B, they're not overlapping, and so they can't happen at the same time. They don't have anything in common. But if I draw them like that, we have this overlap, and that's when they're not mutually exclusive, and so we end up counting this space in the left circle and in the right circle, and so we've counted that space twice. So that's where we subtract away this portion. So that's going to make a lot more sense in a minute when we do a problem together. So this is straight from the book. Take a second, pause, and read this. So we have some students here that live in a campus residence hall, and some participate in a meal program, and some of those students both live on campus and participate in the meal program. You'll find out soon enough that you don't always live on campus and you don't always participate in a meal program. And so what I want to do is answer the question, what's the probability that a randomly selected student either lives or eats on campus? So this is an or probability. I'm going to define the letters that I use. I'm going to say L represents a student living on campus, and M represents a student having a meal plan. And I'm going to draw a Venn diagram to sort of visualize what's happening here. So I have a living on campus circle, and I have a meal plan circle, and they overlap because they told us 42% of these students do both. So they're not mutually exclusive because they have an overlap. So my 42% of students who live on campus and have a meal plan are right there in the middle. I had 56% that lived on campus. So this area here in the circle represents all the people who just live on campus. And so I do 0.56 minus 0.42. This area of the circle represents the people who just have a meal plan. And so of those 0.62, I subtract away the 0.42 that were already on the picture and get 0.2. My probability always has to add up to 1, so 13% live on campus, 20% just have a meal plan, 42% do both, and that leaves 24% that don't fall into either category. So those are people who live off campus and don't have a meal plan. Something probably you do when you're an upperclassman. So if we want to use the formula, we're looking for the probability you live on campus or have a meal plan. So that is adding the probability of living on campus plus the probability of having a meal plan and subtracting away that overlap, which looks like this, 0.56 plus 0.62 minus that 42% who do both, which gives us a 0.76 probability if I randomly select a student that they live on campus or they have a meal plan. And so you could have found that out too by making this Venn diagram and just adding these three pieces together. You'd find out that that adds to 0.76. So we can take this a little further using the Venn diagram. We want to know the probability a student lives off campus and doesn't have a meal program. So in our notation, the living off campus is the complement of living on campus. Not having a meal plan is the complement of having a meal plan. And so that's this area here that we found on the Venn diagram. That's 0.24. And then last, we want to find the probability somebody lives in a residence hall but doesn't have a meal plan. And so if we look back up at this Venn diagram, this area here in the circle are people who live on campus but don't have a meal plan, and that's 0.14, probability of 0.14. So Venn diagrams are something you did in geometry and might be a little rusty with, but they're very helpful when talking about probability. Another thing we'll talk about a lot is conditional probability. What is the probability given that some event has already taken place? And so we have a formula for that. Let's see if I can fix this a little bit. If I want to find the probability that this says the probability that event B happens given event A already happened. So again, the probability event B happens given event A already happens. We find the probability that they both happen at the same time and divide that by the probability of A happening in general. So we go back to our college situation. Sorry, when I change computers, the formatting gets bad. So we're in a dining hall on campus that only allows students who have a meal plan to come in. So in order to run into a student there, they have to have a meal plan. And so you meet somebody who you find interesting, and you want to know the probability that that person lives on campus. So we're already given an event that the person has a meal plan. So we want to know the probability that this person lives on campus given that they have a meal plan. So first we need to find the probability of living on campus and having a meal plan. We know that to be 0.42. Divide that by the probability of having a meal plan. We know that to be 0.62. And so this is just a simple division here and get the probability as 0.677. So given that you're talking to somebody who has a meal plan, you know they have a meal plan, the probability then that that person lives on campus is 0.677. So in fact, the probability of a person living on campus, given that they have a meal plan, is higher than the overall probability of the students at that school. And the last thing we're going to talk about today, and we're going to be able to practice a lot of this and ask lots of questions in class, is independence. So we know that two events are independent when the probability of an event happening is equal to the probability of an event happening given another event has happened. So the probability of B happening here, if that's equal to the probability of B happening given that event A already happened, if those two probabilities are equal, that means A had no influence on B, and those two things are independent. And so I'll just give you an example here. Here's a contingency table. We looked at these in the first unit of the year. And so I want to know if the probability, and let me give you a little setup here. Boys and girls were asked what the most important thing to them was in school: to get good grades, be popular, or play sports. And so we want to know if the probability of getting good grades and of being a girl are independent. So we're going to look at the probability of getting good grades and the probability of getting good grades given that you are a girl. So the probability of getting good grades would be, or of that being the most important thing to you, sorry, would be the number of people who said grades were most important divided by the total number of people, which is 52% or 0.52. The probability of wanting to get good grades given that you're a girl, so we need to find the probability of that getting good grades was what you wanted to do and you're a girl. That would be 130 over 478. And then we want to know the probability of being a girl, which is 251 over 478. And so when we have these two fractions here, what happens is those denominators cancel, and we get this fraction 130 over 251, which is approximately 0.52. And since both of these probabilities are almost exactly the same, we did a little rounding, that means that wanting to get good grades the most in school and being a girl are independent of each other. One does not influence the other. So we went through a lot in a very short amount of time. We have plenty of time in class to practice, for you to ask questions, and for us to understand this better.